In today's lesson, we are going to learn how to solve quadratic equations. And remember that the way that we know this is quadratic is because this lead term has a degree of 2. That exponent right there in the front is a 2, which is how we know it's quadratic. And we now have an equation that we need to solve. So back in the good old days when we were solving more basic linear equations, if we had a variable on the same side of the equal sign, we could typically just combine them and then isolate the variable to solve. However, we can't combine these because they're not like terms, because this one has an exponent of 2 and this one has an exponent of 1. So we're going to have to use a different strategy. We spent previous lessons learning how to factor, and today we're going to actually use factoring as a strategy to solve this equation. So I'm going to pretend for just a minute that 0 isn't there for the moment. I'm only going to focus on this side of the equation, that trinomial. So hopefully you remember from previous lessons that you need to, first of all, when you're factoring a trinomial such as this, the first thing you want to do is look and see whether or not you have a greatest common factor that you can factor out. So your very first step is always going to be to look for a greatest common factor. So I'm looking at those 3 terms, and there is nothing that I can factor out of all 3 of those terms. So in this case, we don't have one, but I've still completed step 1. So remember that step 2, when we're factoring a quadratic trinomial such as this, my first thing that I'm going to do is I'm going to set up my empty binomials. So these are actually notes from a previous lesson. Oh, would help if I spell binomials right. Sorry. So because I know this is a quadratic trinomial, I'm probably going to end up with 2 binomials. I'm going to pop it open just like that. So the next thing I'm going to do, hopefully we recall from this, is that we're going to factor that lead term. So we're going to factor that lead x squared in this case. And the only way that we can factor an x to the second power is simply with an x times an x. But then we need to figure out what the other terms are going to be to go into those binomials. So now we need to set up that chart, and this chart should look familiar to you. So we need to figure out, what do we multiply to get C? So in this case, C is negative 21, because that's the constant that's there by itself. So what are we going to multiply to get C that will add up to get B? And in this case, B is a negative 4. So we've got to think about what those factors of 21 would be. So I would do 1 and 21. Because this is a negative 21, I know that one of those 2 factors is going to have to be negative. So the 2 options I have is it could either be a negative 1 and a positive 21, or it could be a positive 1 and a negative 21. Neither one of those adds up to negative 4, though, so I'm going to have to try something else. 2 isn't a factor of 21. 3 is, so I'm going to do 3 times negative 7, or it could be negative 7 times positive 3. And if you noticed, I'm actually going to go ahead and stop right there, because I can see that negative 7 and positive 3 are also going to add up to negative 4. So I have found those 2 numbers that I need. So what was the whole point of finding those 2 numbers? Well, now I can just take them from step 4, and I can put them right up there in those binomials. So this is going to become x minus 7 and x plus 3. So the first step is just factoring that left side of the equation, just like you factored polynomials in the past. So our first step is just to completely factor that left side of the equation. So I kind of have been ignoring this right side of the equation. So now I need to actually use that. So I'm going to take my equation and I'm going to rewrite it as the fully factored form that we just got. So I'm going to take my x minus 7 and x plus 3 and set it equal to 0. So this is, I'm going to do my fifth step, which is now to find the zeros. They're also called finding the solutions. Two different ways of saying exactly the same thing, okay? It really means exactly the same thing. So I've got my factored equation here. X minus 7 and x plus 3 is equal to 0. So we know from previous background knowledge that 0 times anything is obviously going to be 0. So either this is equal to 0 or that is equal to 0. So we need to figure out for each of those binomials, what would the value for x be so that x minus 7 equals 0. And obviously that would be a positive 7. And then what value for x would make this one, this binomial, equal to 0? That would be a negative 3, because a negative 3 plus a positive 3 would be equal to 0. So those are my two solutions. Typically, we write it using this particular type of notation when you actually have more than one solution. It's those brackets that you guys know I can't draw. If you've been in my class, you know I stink at that. Typically, we put the smaller one first, although it doesn't really technically matter. So this is how we do the set notation. It's negative 3, positive 7 with brackets on either side. So now that you've seen an example, it'd be great if you pause the video for a second, try to work this one on your own, and then unpause the video to check it. I'm going to assume you probably did that. So I can see once again that I have a quadratic trinomial. So I am more than likely going to just pop open those binomials. Again, I'm going to kind of ignore that side for a minute. My next step is that I know I need to factor that k to the second power, and the only way to do that is to do a k times a k, and then I need to set up my table. I need to figure out what am I going to multiply to get c. So in this case, what do I multiply to get 30, that I'm going to add to get b, so what I would add to get negative 11. So let's think about those factors of 30. And because they have to add up to a negative 11, I know that more than likely I'm looking for two negative numbers, because a negative times a negative will still give me the positive 30 that I need over here. So I could have a negative 1 times a negative 30, which obviously doesn't add up to negative 11. Then I need negative 2 times negative 15, still doesn't add up. Negative 3 times negative 10 doesn't add up to negative 11. 4 does not go into 30. Negative 5 times negative 6. Oh, there we go. There's the one that actually adds up to negative 11 as well. So I'm going to take that negative 5 and that negative 6 and pop them into those binomials. So it's k minus 5 and k minus 6. Now I'm going to deal with the right-hand side of the equation that I was kind of ignoring for the moment, and I'm going to find the zeros. So what value of k would make k minus 5 equal to 0? Well, obviously that would be a positive 5, because 5 minus 5 would be equal to 0. And then what value for k would make this one a 0? Well, 6 minus 6 is equal to 0. So that's how I know that my two solutions are going to be 5 and, oh, meant to put a comma there, 5 and 6. I'm going to do one more for you of this type, and then I'm going to show you another special case in just a second. Hopefully, I want you to pause the video, try to work this out yourself, and that now you've tried it and you're just watching me to check yourself. So my first thing that I've got happening here is I can see it's a quadratic trinomial. So I'm going to pop open those binomials. Again, I'm going to ignore this part for right now. To factor that x to the second power, I know it's going to be an x times an x. And now I need to figure out what am I going to multiply to get c. So in this case, what am I going to multiply to get negative 14 that I'm going to add to get b, that I'm going to add to get 5. So because this is a negative 14, I know that more than likely one of my numbers is going to have to be a positive and one is going to have to be a negative. So it could be either positive 1 and negative 14, or it could be negative 1 and positive 14. Neither of those adds up to 5. I could do positive 2 and negative 7, or I could do negative 2 times positive 7, and then, yay, there we go, right there. Those are my two that are also going to add up to 5. So I'm just going to take them, I'm going to pop them over here, so it's going to be, oh, not x plus 2, x minus 2, and x plus 7. Now I need to pay attention to the right side of the equal sign, because now I need to get my zeros. So what value for x would make this binomial equal to 0? Well, obviously 2 minus 2 would be equal to 0. And then for this one, a negative 7 plus 7 would be equal to 0. So my two solutions are negative 7 and positive 2. All right, so this one is an example of one that's a little bit of a special case. So I wanted to make sure I showed you how to get started. So you notice it's quadratic, but you only have 2 terms this time. So remember that typically when we have the 3 terms, it typically looks like this, right? You have the exponent of 2 in the front, then you have the variable with just an exponent of 1, and then you have the constant that is the third term by itself. So use that to help you figure out which one of those terms is technically missing. So if you look at it, you can see you should have n to the second, and it's the regular, you've got the regular constant, so that's going to go at the end, right? So it's the regular old n that you're missing in the middle. So in order to do that, you're just going to do plus 0 n. So that then you're going to pop open your binomials, just like normal, and you're going to factor the n squared by doing an n times an n. And when you set up your table, you're going to do, what do you multiply to get c? So what multiplies to get negative 64, that adds to get b, which in this case is a 0. So when you're doing your factors, I know negative 8 times positive 8 will give me negative 64, and that will also add up to 0. So that means it's going to be n minus 8, n plus 8. Then I go through with my procedure of finding my zeros. Obviously, what would make this equal to 0? 8 minus 8 would be equal to 0. And then here, it would need to be a negative 8, because a negative 8 plus a positive 8 is equal to 0. So the two solutions are a negative 8 and a positive 8. So make sure that you have all 3 of your terms accounted for so you can do your regular strategy, and if not, you just need to put in a 0. Okay, this one is another one of those examples that appears to be missing a term, but this time you have the variable to the second power and you have the x, so it's actually the c that you're like kind of missing. So instead of putting the missing term in the middle, this time you'll rewrite it x squared minus 7x plus 0 is equal to 0, because it's the regular old number that you're missing. So when you factor it, you're obviously going to do your x to the second will be x times x. So then when you're setting up your table, you'll do, what do you multiply to get c, which in this case is 0, which will add to get negative 7. That's your b. So what really 0 times anything is going to be 0. So you know you're going to do 0 times something. Well, 0 times negative 7 equals 0, and then it also adds up to negative 7. So you know that those are the two. So you're going to fill in those binomials with a negative 7 and a 0. So what are the zeros that'll make this equation true? Positive 7 minus 7 will be 0, and then 0 plus 0 will be 0. So your two solutions are 0 and 7.